How many transistors are in an op-amp? Imagine a tiny electronic brain that can amplify signals and make your gadgets smarter. That's what an operational amplifier integrated circuit does. But have you ever wondered how many tiny switches, called transistors, are packed inside one of these chips? Well, the answer depends on the type and complexity of the op-amp. A classic example is the famous 741 operational amplifier. This device has about 20 transistors inside. These transistors work together to perform different tasks. The main parts include the differential input stage, the gain stage, and the output stage. The differential input stage usually has two transistors that compare the voltages at the inverting and non-inverting inputs. This stage turns the voltage difference into a current. Next, the gain stage amplifies this current further using several transistors arranged to give high voltage gain. The output stage then provides enough current to drive the connected load, like a speaker or a sensor. It also has transistors that protect the circuit from damage if something goes wrong. In the classic 741 design, the transistors are mostly bipolar junction transistors, which are good at handling high currents and switching quickly. These transistors are arranged in pairs, mirrors, and amplifiers to make the op-amp work smoothly. The design also includes transistors for biasing, which helps the circuit operate at the right levels, and for internal compensation, which keeps the amplifier stable. Modern operational amplifiers, especially those made with complementary metal oxide semiconductor technology, might have more or fewer transistors depending on what features they include. Some high-performance op-amps can have over 100 transistors, especially if they are designed for very high speed or precision. But the core building blocks stay similar: input differential pairs, gain stages, and output transistors. Knowing how many transistors are inside an op-amp helps engineers understand its performance. It influences how much noise it produces, how linear its output is, and how much power it consumes. This knowledge is useful when choosing the right op-amp for applications like signal filtering, analog calculations, or sensor interfacing. So, next time you see an op-amp, remember that it's a tiny powerhouse made up of dozens of tiny switches working together to make your electronics smarter.